Hello, I'm Daniel Beltram, and I'm presenting the flyweight pattern for CIS476. The flyweight pattern is a structural design pattern used to optimize memory usage and performance when dealing with a large number of objects that share common characteristics. It achieves this by separating objects' intrinsic state, which is shared among multiple objects, from its extrinsic state, unique to each object, and storing intrinsic state externally, typically within a flyweight factory. This pattern is useful when you need to create a significant number of similar objects and want to memorize memory footprint. The advantages of flyweight are that it reduces memory consumption by sharing common object data, improves performance in applications with many similar objects, and minimizes object creation overhead. Disadvantages of flyweight are that it increases complexity due to separation of intrinsic and extrinsic data, requires careful design to manage shared and unique states, and it's not suitable when objects are highly unique and cannot be shared. One example of flyweight pattern is vehicles in a racing game. There's usually only one shared model per created vehicle, but it might be personalized based on the character using it. I brought this up because my demo goes in depth on the topic of a shared vehicle model. Another example is different intersections are using the same traffic signal types instead of creating new ones each time. The signal type is intrinsic and the intersection is extrinsic. One more example is that thousands of characters share the same font size and style, while position and content vary. The font size and style are intrinsic, and the position and content are extrinsic. This is the basic structure of a UML pattern of a flyweight. You have the interface. The flyweight factory implements that interface. The concrete flyweight holds an intrinsic state and gets an extrinsic data from an object via an operation. It is dependent on the flyweight, and the client is the manager. It is dependent on the flyweight factory and the concrete flyweight because it uses those together. Because C++ doesn't have an interface, I added a context class to hold intrinsic, extrinsic data to set, and the client, uh, the client is an aggregation of that context. The client is also dependent on the flyweight factory. The context is dependent on the interface. The concrete flyweight and the factory work together, and the factory inherits. Sorry, no, it doesn't. The concrete flyweight inherits the flyweight interface. Flyweight interface is the base class or interface for the shared item. Concrete flyweight is the specific item itself, and it uses intrinsic data. Also has private constructors similar to Singleton. However, unlike Singleton, the getter method is not in the same class the private constructor is. The flyweight factory is the class that contains references to flyweights, making sure only one geometric render exists by having a private static pool map of strings to flyweight interfaces and a public static getter method. The context represents a specific instance using extrinsic data, and the client is the class that manages specific instances and flyweights together. This is the UML diagram of my demo. Yeah. You got your vehicle model interface interface. You got your concrete vehicle. You got the factory of the vehicle, and you got your specific instance and your manager. In my demo, vehicle model is the flyweight interface. Vehicle is concrete flyweight. Vehicle factory is flyweight factory. Instance is context, and manager is client. The job of the vehicle model creates the pace model. The vehicle provides a concrete model using intrinsic data of the model's geometry. Vehicle factory's job is to make sure that no more than one unique geometric model is generated for each vehicle. Instance's job is to handle extrinsic data of the model, which is the color, the position, the size. Manager's job handles rendering specific instances, and the main runs the examples of the rendering in action. This is just the test run of my demo that I ran earlier. This is the output. Everything runs as it should. These are just the references for this presentation.